Hey Rams, hope all is well. I'm just sitting here with my daughter. Jessie, say hi.
Hi.
And we're going to do 11.6, the areas of circles, areas of segments, and areas of sectors today. A lot of this information is review from chapter 10, and we'll just build up on it a little bit. Just to remind us, a sector of a circle is a region bounded by the two radii. Now remember, imagine this being the center of our circle, and the circle is extended out to here. It's a great circle, Mrs. Manukian. And it's saying that it's a region bounded by the two radii. Here's one, and here's another. Two radii of the circle, and the arc intercepted by the radii. So between these three things here, the two radii and the arc, we are going to be talking about the area of this sector today. Another definition, now this is going to be new, it's segment. A segment of a circle is the region bounded by a chord, and so we know that this is the chord and the minor arc. This is our minor arc. It's the one that's under 180 degrees. Now the segment isn't just a standard segment of a line. When we're talking about a segment of a circle, we are talking about this area, the area bounded by the chord and the major, or in this case, the minor arc. Okay, now let's get started on this one. So here it says, find the area of a circle with diameter 16. Let's get started on that. I've got diameter of 16. And to find the area of a circle, the area is formula is pi r squared. So I need my radius. Now if the diameter is 16, my radius is 8. So I'll plug it in here and I'll get pi 8 squared, which gives me 64 pi units squared, and that is the area of my entire circle. Now the next question says, what would be the area of a sector of the circle above if the angle between the two radii of the sector was 90 degrees? So I have one of my radii here, which is 8, and I'm going to make another one to make a central angle of 90 degrees, just like it states. And this here is 8. So they're asking me for the area of this entire sector. And we did this from our previous chapter, if you remember. We took to find the area of a sector, we did theta over 360 and multiplied it by the area of our entire circle. We know the area of our entire circle, it's 64 pi. So theta here is 90. We'll put 90 over 360, and we'll multiply it by the area of our circle, which is 64 pi. And let's just start reducing this over here. 90 divided by 360 gets reduced down to 1/4 times 64 pi. And I simplify that and I get 16 pi units squared is the area of my sector in between the two radii with a central angle of 90. The last one says draw the picture here, and we did just that. All right, let's give this one a shot. Tom has ordered a 20-inch pizza. If he ate 40 degrees of the whole pizza, comma, how much in square inches of the pizza did he eat? All right, so let's have this pizza here. And it's 20 inches, so I'm going to say my radius automatically is going to be 10. And it says he ate 40 degrees of the whole pizza. I'm going to put my other radius over here of 10. That's 10. And it says it's 40 degrees, so I'm going to write my central angle is 40 degrees over here. Okay. How much in square inches of the pizza did he eat? In other words, they're asking me for the area of this sector created by the two radii. And so the area formula that we used from chapter 10 was we would take theta, divide it by 360, and we multiplied it by pi r squared. And in this case, here I'll simplify it and get pi 10 squared. And let's just keep working with this equation, and eventually we would get 10 over 9 pi inches squared, and I know you guys like it all in decimals, and so that's approximately 3.49 inches squared. And again, this is repeat of chapter 10. All we did was take theta, divide it by 360 to get our proportion, and we multiplied it by the area of our entire circle. Now this is something new. Let's put our thinking caps on. Find the area of the segment That's that shaded region. Remember, we introduced that definition earlier today. And so basically what they're asking me to do is to find the shaded region. So what I should do is find the area of my entire sector and then subtract from that the area of my triangle. And I'll be left with the area of my shaded region. So let's do step one. Let's find the area of my sector. Area subsector. And the way I do that is I do 120 divided by 360. Remember, that's my proportion. And I'm multiplying it by the area of the entire circle, which is pi r squared. Once I simplify all of this, I get 12 pi. Now this is the area of my sector. Next step is I need to find the area of my sub-triangle here, and eventually I'll subtract those two out. The formula for area of a triangle is 1/2 base times height. Okay. Now I know my base, I'll find it, and I'll figure out my height based on the fact that the central angle is 120 degrees. If the central angle is 120 degrees and I know that all three of my angles have to add up to 180, I'm going to do 180 minus 120 and I'll get 60. 60 is going to be the total degrees of each of these side angles here. Is this an isosceles triangle? Yes, it is, because both legs are made by the radius. Now what I'm going to assume then that these are each 30, because they both have to be 60. Remember, I solved for that there. Okay, last step. I'm going to get a height. Now I have a 30, 60, 90 triangle here, right? The 30, 60, 90 triangle with a hypotenuse of 6. That means that the short leg will be 3, which means that the long leg will be 3 root 3. Now I need to find the area of this entire triangle, 1/2 base times height. Now the base is not 3 root 3. The base is 6 root 3 for the entire length. So I'll do 1/2 6 root 3 times my height. My height was my short leg, which is 3. Again, 1/2 base times height. I found the base here to be 3 root 3 based on my small 30, 60, 90 triangle, and my height here was 3, again based on my small 30, 60, 90 triangle. Now to find what I'm looking for, which is the area of my sector here, I have to subtract the area of the triangle by the whole entire sector. So I have to do 12 pi minus whatever I get up here. Now let's keep simplifying that. The area of the triangle is going to be 1/2 18 root 3, which becomes 9 root 3. So I have to do 12 pi minus, change that to minus 9 root 3. And 12 pi, I know you guys like decimals, is 37.7 minus 9 root 3 is 15.6 because you like decimals, and so my answer will be approximately 21.1 units squared, or you could leave it like this with units squared as well. It's actually more accurate. So again, to find the area of this segment, we found the area of our sector and subtracted from it the area of my triangle. Let's keep going. Okay, before we do more problems, let's just define this segment area. Describe in your own words how one would find the segment area. And so what I would say we would do, we did it in our last one, we would find the sector area. And the sector area we could find by the space that's between the two radii. Then we would subtract the area of the triangle that the two radii and chord created. In other words, we have a circle, we have our sector, and a triangle, and the segment area is this space here. We would find the sector area, We would find the area of that triangle, subtract it, and we'd be left with the segment area. That's the new concept of this section. Okay, we've got one more. This one should be no problemo. Find the area of the shaded region. That shaded region there is the sector area. Okay, this is what I'm going to be drawing in now. That also is 4. Now I know if I go diagonal to diagonal in a square that I have a right angle here. So let's figure out how we do this. First, let's find the area of the sector. Always first step. In that area, we're going to take our proportion from our last chapter, 90 over 360, and multiply it by the area, which is, the area of the circle, which is pi r squared. Simplify that, and we get 90 over 360 times 16 pi. Keep working that, and we get 4 pi. That's the area of my sector. Now I'm going to try and subtract out the area of my triangle. Area formula for the triangle is 1/2 base times height. 1/2, the base is 4. The height of the triangle is also 4. And so when I simplify that, I get 8. So the way to find the area of the sector here is to take, of the segment region here, is to take the area of the sector, which is 4 pi, and minus that from the area of my triangle, which was 8. Now I know you guys don't like leaving it in this form, and so we could find our decimal. 4 pi is 12.56, subtract 8 from it, and we get 4.56. This is our homework assignment for the day, and the next slide I'm going to ask us to do in class is our ticket out the door, but we could go ahead and wrap that up here together. Alright, so this one, find the area of the shaded region. So I'm looking for what is in gray. So the way to do this, let's find the area of my entire square first and subtract out the area of my 4 circles. So the area of my entire square is always going to be base times height. So I'll get 24 times 24, and in my calculations I get 576 units squared. Okay. Let's focus on the area of one circle. It's pi r squared. Let's find what r is. So if all of this here makes up 24, and it's cut up into 4 equal segments, if you agree with me on that, this is equal to that because they're both radiuses, and I've got that there and that there. So I'm going to do 24 divided by 4, which equals 6. And that's how I'm going to determine that each radius here is 6. So let's find the area of one circle, pi r squared. It's going to be pi times 6 squared, and I get 36 pi. Now that's the area for one circle. I need to subtract the area of 4 circles. So I'm going to do 4 times 36 pi, and that's going to leave me with 144 pi. So how will I find the area of the shaded region? I'm going to take 576, subtract 144 pi from it. And again, I know you guys don't like leaving it that way. And when you do 576 minus the quantity 144 times 3.14, you get approximately 123.84 units squared. Both of these are valid answers. One is an approximation, the other one is exact. And there we go. See you guys in class.